Hello apes and welcome back. We are in chapter 3. This is our 5th in our screencast series and we're talking about evolution, biodiversity, population, ecology. So we've gotten through the evolution part and now we're talking about the biodiversity, and we were leaving off with endemic species in the last screencast, and now we're going to look at other species that are especially vulnerable to extinction. And one of those organisms that inhabits the U.S. are amphibians. Because they have very, very small ranges. And when we say ranges, we're talking about temperature ranges, feeding ranges, amount of humidity, pH of the soil. So because of their sensitivity, and I can say if you ever had a pet amphibian, maybe an iguana or a gecko or some kind of little lizard, you know that you've got to have a heat lamp on and you have to maintain the humidity in there. There's a lot of things in order for that to survive, and that's the same thing out in the environment. So because of those needs, they are very vulnerable to extinction. So a good example is the Yosemite toad or the Houston toad or the Florida bullfrog. So we'll talk about those species. So let's start with the Yosemite toad, and this is restricted to a region in the United States that makes up the Sierra Nevada in California. And the Houston toad occupies just a few little areas in a Texas woodland, hence Houston. And the Florida bog frog lives in a tiny region in the Florida wetland. There's about something that we have on here. There's about 40 salamander species in the United States that are restricted to area based on the size of a typical county. And some of these live on top of single mountains. So I think we have a picture of a salamander. I used to catch salamander in the streams when I was little. We would turn over the rocks and we would find these salamanders, and I thought they were pretty cool. And in Florida, I'd taken my sons to Disneyland, and Brian was chasing one of the salamanders that they have there, the little lizards that they have there, and it stopped and he accidentally kind of squished it because he was still running when it stopped and his foot came down on it and he cried the rest of the night. But these are subject to living in particular climates, and they cannot adapt to living in any other climates. So if the temperatures are changing, the amount of moisture are changing, then there's a great chance that we're going to lose this species. So when we take a look at the extinction rate in our history, we see that the background extinction rate was kind of a constant, very slow rate of extinction that just happened as a part of evolution. It was as slow as evolution. And we can see also in history that there were some episodes of mass extinction events that occurred widely, and they were at spaced intervals in the Earth's history that really wiped out about 50 to 95% of the planet's species. One of the first ones that we can go back to is about 65 million years ago, and that brought an end to the dinosaurs. We do believe that some of our modern day birds that we have are actually representatives from those dinosaurs that were able to survive for whatever reasons. The evidence suggests that the impact of a gigantic asteroid actually caused this event, and they called it the Cretaceous Tertiary or KT event. And that happened about 65 million years ago, as I said. Then there was another mass extinction at the end of the Permian period, which was about 250 million years ago that happened. And this is where paleontologists estimated about 75 to 95% of all species went extinct during that time. They called this the mother of all mass extinctions, and there is an appendix in your textbook, Appendix E, that talks about these geological periods and this Permian period. So where are we now with this? And I want to go back. Before I go on, they think this mass extinction was actually happened also because of an asteroid impact, but they also felt that during this time there was massive volcanism going on, so a lot of volcanic activity happening, and a lot of methane being released as a result. And the methane obviously is toxic and also contributed to an extreme global warming event that took place. So they don't know for sure, but from the geological evidence, they see a combination of factors that could have been at play for that extinction. So we're looking for, there's been 5 mass extinction events in total, and hopefully in class we'll get to see videos, and you'll see that MOA, where there's no MOA of that. They think that the 6th mass extinction is coming upon us, and they believe that humans are the cause of this 6th mass extinction event that's going to happen. They are seeing that by doing something called a Millennium Ecosystem Assessment, that it's estimated that today's extinction rate is about 100 to 1,000 times higher than the background rate and is rising. And it's happening because we're destroying natural habitats. We're cutting down rainforests. We're plowing under prairies. We're building permanent structures. I often get into discussions of climate change and saying that climate change is a result of the large number of human population and the habitat destruction that goes on. And people will challenge me, and that's good. I like to be challenged. And they'll say, no, humans can't do that. Look at the dinosaurs. The dinosaurs did more damage, and they're extinct. But what about them? They're not causing the change in the climate. They didn't cause that. And I have to go back and say, if a dinosaur ate a tree, cut down a tree, knocked down a tree, there would be other plants and things to take its place that could grow in that spot. Where if a human destroys a habitat, we're putting up subdivisions, we're putting up malls, we're putting in roadways, and that's permanent. Even if you go and I love exploring old buildings, old houses that once had families, and I just think the history in it is just really, really super neat. But that's permanent. We can get some vines and twigs and stuff growing over it over time, but it's still standing in a spot. It's taking up a place where living systems could be. So our destruction is more permanent, and we can't have that succession that would happen. Another thing is we hunt and harvest species, and we hunt and harvest species to extinction. Right now we're battling keeping the elephants alive. I think the last count, there's about 3,000 elephants alive on the planet, and they're getting hunted illegally for their ivory tusks. And we have all different kinds of policies in place, sites, and the Endangered Species Act that puts tremendous fines and prison time for hunting it. but people are still hunting because there's still people that are demanding ivory in the black market. So we're losing a valuable species. The latest I've seen is they're staining the tusks hot pink so that they're no longer valuable. So there's elephants walking around with hot pink tusks as a way of preventing poachers from getting them. We're introducing non-native species that are impacting other species. You know, we talked about a little bit, I mentioned the zebra mussels. We're going to spend more time on that. They actually will settle in areas that were breeding areas for fish that were part of the fishing industry. So if they can't breed in those areas, it's going to cut the numbers down. So again, it's problematic. And here's the thing. Life's just not going to just rebound. It's going to take millions of years for the life that we've destroyed, that we've lost, to recover. Overall, the whole grand scheme of a picture. We can plow over under a prairie and we can leave it, and with succession through time, maybe 50, 100 years, it might come back. Will it come back to what it was from being there for centuries? No, not in that short period of time. But in a few more centuries, yeah, if it was left alone. So it's not something that we can fix overnight. It's a long-term fix, and we need to be aware of that. Oh, let's see if this fun thing works here. The last one did not. Oh, I think we tried. Whoops. Let's go back. Right click, play. And we're watching for something to happen. And I'm not seeing anything happen. And we tried to move this before, and it didn't move. So, oh, look, there's a question mark that just popped up. I wonder what happens if we click. Oh, here we go. So we can see the idea of evolution of 4,600 years ago, a million years ago. I'll get it right, where we're unicellular. And then we get into the Paleozoic area, the Precambrian area, where we've got this primordial soup that is developing fish-like organisms that will eventually crawl on the land, and then we're getting plants and snakes that are developing. And then we should be getting in closely into, oh yeah, here's our Mesozoic time, our Triassic period, with all of our dinosaurs. You can see the woolly mammoths that's there. And that small little section at the end should be where human life comes in as we continue to watch this evolve. And there we are. So we can see in that last chunk, that's where we fit in. Okay, we got it to work. Yippee! All right, so here is the next, and oops. And if I keep messing this up, we might run out of time. Let's play this one. And I'm not seeing anything happen here. Oh, there we go. So this shows macroevolution, and it shows evolution on a larger scale, how one bird can evolve into all of those different species that you're seeing there, like Darwin's finches. And that's done in a phylogenetic tree, a small branch of that tree. All right, let's end this here, and we'll continue in the next screencast. Oh, look, it's continuing. We can see how these dinosauric type birds evolved into the birds that we know today. All right, we're ending it here.